It is a great pleasure today to welcome Ericka Johnson, author, professor, researcher, sometimes debater, I think, as well. I when I looked to see how should I describe your work, I found on your webpage and it said, much of my work has looked at data about bodies, human and robotic. And I thought, okay, if that's not an enticing line, I should have included to drag people in what could be. So we've had a little bit of a cooperation now looking at how to describe synthetic data. From our point of view, it's like we want people to describe data in a way that's reusable. But Ericka has enlightened us that there's a lot of other issues with synthetic data too that people need to be aware about. So with that, I'll hand over to you, Ericka, and welcome.
Thank you very much. Thanks, David. And I will mention that during the course of our conversations, David and I have been talking about metadata, readmes, the complexity of synthetic data. And then when we were talking about this workshop, we came up together, though I think maybe it was mostly your suggestion, David, that we would talk about, or the title would be Synthetic Data, Bias, and Metadata for Transparency. And I like that title. I'm a professor of gender and society, so bias is one of these things that I think about a lot. But actually, I have an alternative title here. Let's see if I. So you want to share your synthetic data? Let's talk. And that's really what I want this conversation to be about. I'm going to go in a little bit towards representation, which is one of the first steps towards thinking about bias. So we will be talking about that. But mostly I want to talk about what synthetic data is and maybe what it could mean or not mean for open science and the general concept around open data. So I am not entirely sure that everybody here knows what I'm talking about when I talk about synthetic data and maybe has different ideas about what it is. So one thing I thought I'd first start out with is that this presentation and the conversations that David and I have been having have been about AI-generated synthetic data. So Gen AI is changing a lot of things and it's making a lot of synthetic data. But synthetic data is something that we have been living with for a long time, especially in population data, census data, but also any sort of data that you would have made from a model or statistical, regressions to fill in missing data. All of this could be at some level called synthetic data. However, the work that I've been doing more recently has been collaborating with a machine learning researcher and analyzing what happens when you do generate synthetic data with machine learning techniques. And those are the ones that I think are creating a need to have a different conversation about what we're doing with synthetic data and how it can be shared. That said, synthetic data can still mean a lot of things, even if we're talking about AI-generated data. So we have lots of generated images out there. These are really often used for training self-driving cars, for example, when you need to have lots and lots of images to train the cars and different robots on, or, if you want to make a political statement, also synthetic data. We have text style synthetic data. So everything that you're getting out of these like ChatGPT or other types of AIs that we call, from large language models, that's also synthetic data. And people might push back a little on that. We can have a conversation there too if you want, but it's synthetically generated data. The stuff I'm going to be talking about today, however, is the type of synthetic data I think that a lot of data repositories are going to start to be receiving, and maybe we need to think a bit more about, and that's tabular data. So what happens when you use different methods from machine learning to generate tabular data, and how do we need to be clear about that? Why in the first place would you do that? So I've sometimes asked myself that question too, especially when I've looked more closely at what happens in the tabular data when it happens. But there are really good reasons for wanting to have synthetic tabular data. A lot of it has to do with the way that we currently have data restrictions and regulations around, for example, ethics, or sharing data across nation state boundaries, or sharing data across domains, or sharing data between organizations, or sharing data within organizations. There are lots of different structures that place restrictions on who can access which data. And one of the dreams of synthetic data is that you would be able to generate synthetic data from real data that would still represent that data, and then be able to share it and get around all of these different restrictions and some of the data regulations that we have. This is probably true right now. I don't know how long that will be true. I think that we have regulations that will eventually change there as well. I don't know. But right now, that probably is a good reason to be using synthetic data. Good has a moral overtone there that I'm not sure I want to bring with, but okay, we can leave that somewhere else. Another reason for generating synthetic data is that there are people who think that maybe it could ensure privacy. And I think that there's a huge conversation to be had around this, even around like what privacy is versus anonymity and, how we can ensure these things. That's not going to be the conversation we have today, but it is one that we need to talk about. However, synthetic data is sometimes put out there as a solution to privacy issues with data. And you see this a lot of times in, for example, the use of population data or patient data. I just think the idea is that synthetic data might solve these problems that lead to then restrictions. Another really big reason for using synthetic data right now, synthetic tabular data, is that we have a lot of data to train machine learning algorithms on and to train these AIs on, our AI models, but we often don't have enough data because you need a lot of data. And even if you have a lot, you probably don't have a lot. So we have to figure out how to make that big amount of data. And synthetic data is put forward as a solution to that, where you could use machine learning techniques, AI, to again, read and learn the essential aspects of your data, and then generate new data that is slightly different, but still the same. And for that reason, you could use that new data that would then augment or amplify your existing data and let you be able to train your AI models on it. So these are some good reasons why you would, if you were a researcher or somebody else were, really interested in data, think that synthetic data might be a good solution for you. I sometimes think about Austin Powers when I hear these solutions. But okay, that's me. I tend to be a little bit like, old cringy mom. I like movies from the 90s. Okay, how do you make AI synthetic data? And if you're going to do it, what could possibly go wrong? Well, like I said, you make it by letting an AI, a model, or like a machine learning algorithm, learn the essences of your data. And early on, one of the ways for doing this was by using generative adversarial networks. There still are a lot of models that are generative adversarial networks that are being used to make synthetic data. There are newer ways of doing it too, diffusion models, for example. But whatever you do, what you try to do is let it learn the essential statistical representations in your data. However, if we think about statistical representations and let something learn that and then reproduce it to spit out something new that's similar but slightly different, it's pretty clear that probably what's going to happen is it's going to learn the most common representations and relations first and largely and spit those out and make that. So one of the early thoughts about synthetic data was that, yeah, it would be good, but it's really best for representing the things that are most common in your data. And edge cases tend to go missing. This is called mode collapse. Now, when I started hearing about this was a few years back. Like David said, I'm really interested in how the body becomes data for medicine and robotics and care robots. And I work in a field largely, kind of called the medical humanities. And I started to hear a lot of talk about medical data being synthesized and then getting around these problems with privacy. And that was going to be a big solution for the way that we, with data, represent people and populations. But then in my other bubble, which tends to be much more AI related, I did hear this way, this conversation about, yeah, well, the edge cases go missing, but maybe that's not such a big deal. We're getting the normative ones. And as a gender studies person, I thought, what? I actually think that is probably a big deal because I do know that, for example, in the medical domain, most of our data is still gathered and gleaned from male bodies. And so the female bodies are actually the edge cases in that data, especially if you're looking at legacy data. So if we're going to start synthesizing that a few iterations and letting the edge cases and go missing and throw them under the bus, pretty soon we will be back to the situation that we had pre-1990s, where the medical data that we used to create knowledge about the body or people or populations was largely based only on male bodies, and very specific types of male bodies at that. So I don't know. I thought this maybe isn't such a great solution. Let's test it out and see what happens. So I started collaborating with Dr. Sagi Haji Sharif, who has a background in machine learning techniques. And she and I took some just basic population data, the 1990 US adult population census data, and started synthesizing it. And sure enough, when we looked at it, we saw that this process of synthesization, which we were using first GANs, the generative adversarial networks, had the edge cases go missing. So for example, in the original data, we had 41 countries of origin. So where the adult population of the US was born, most of them were born in the US, and the US was very well represented in our new synthetic data set. But 9 countries went missing from that. And these were the countries that had very few people that were born in them that were currently living in the US in 1990. I'm going to be talking about this data set some more a little bit later, so pay attention here. We started to see that the edge cases were missing at all of the different attributes. And more to the point, we are much more than just our country of origin or our gender or our age or our education level. This is something that the social sciences and especially gender studies has been really pounding home in the last 3 decades, that we are intersectional beings who are intersectionally influenced by lots of different power dynamics in society. And to understand the way that we are people and work in society, we have to think about the complexity of all these different power dynamics and the ways it makes us into complex people. This is true for population data. This is also true for any tabular data set. The reason you collect data in the first place and then organize it into particular ways, particular tables, is because you're interested in the relations between the different attributes in those columns. But for the purpose of clarity, because it's pretty easy to understand intersectional relations with population data, I'm going to keep working with this 1990s adult population set from the US. And here it is. Now, don't panic. I will explain this. This is a SPLOM, a representation of 3-point intersections in the data. The lower left diagonal corner, which has a pretty white background, are 3-point intersections of different aspects of the data set in the real data set. The upper right triangle with the grayed background are the same 3-point intersections of those same different attributes in the synthetic data set. And the diagonal through with the bar charts, those are the statistical representations of the real and the synthetic at the single attribute level. So for example, here we see the age in the real data and the synthetic data. And the brown is the overlap, right? And you can see that at the single attribute level, the synthetic data is fairly close to the real data. And this is good because you want it to be fairly close, but you don't want it to be the same, because if it was the same, then you would have a mirror of your data. And then you wouldn't be able to guarantee privacy. You wouldn't be able to share it over boundaries. You wouldn't be able to get around data regulation. And you wouldn't be able to add anything new in terms of new information to whatever data set you're trying to train your AI models on. So your synthetic data has to be slightly different than your real data, but it should still be pretty much the same. And if you look at this, the diagonal there, you can see that at the single column level, it is pretty much the same, just slightly different. But then, poor Sagi, I was like, you know what, that's great, but what about the intersectional aspects of this data set? So she's like, well, let's look. And here, for example, you can see the age, income, and gender intersection of the real and the synthetic data. And if you look at these next to each other, the real is over on the left and the synthetic is on the right. You can see that here too. The income, which in this data set was binary, high, low, and the age, which was along the bottom, and then the gender, pink and blue. How like gender professor not is that? But anyways, like it is they pretty much also overlap. They're not like identical. Again, that's good because if they were identical, that would be a bad thing for synthetic data, but they're pretty close, which is also good because you want it to be pretty close. But then we looked down here, for example, and looked at the intersection of occupation, marital status, and gender. And what we saw was that, let's see if I saw, was that it was much more pink in the synthetic data than in the real data. So we went back and looked at that particular intersection and like the data points that were being represented there. And we saw that in the real data from 1990 US Census data, there was one female husband. Now, this could be like a data entry mistake. It could also be somebody who wrote that in themselves, because in the 1990 census data, you're able to write in your own, like you answered with pen and paper. It wasn't a multiple choice. So it could be that. In any case, it was 1990 in the US. So this was not like a legal category, but it existed one of them in the data. But then in our synthetic data, we had 259 female husbands, which I thought was really interesting, but maybe an issue. And then we also saw that we had 333 points that were both categorized husband and wife and single. Now, at this point in our collaboration, I was like, whoa, we've got something really interesting going on here. We need to make words for it, because I'm a social scientist and that's what we do. We make words and we think that these are like tools to start analyzing stuff, which I kind of think is true. So I was like, okay, Sagi, let's call the green ones intersectional fidelities and the pink or the orange ones intersectional hallucinations, and let's go out and start talking to everybody and their brother about this, because it's really important that we discuss this and what impact this will have on the use of the data. And Sagi's really diplomatic and she's like, yeah, definitely you should do that. But then she's also an engineer, so she's like, let's also see if we can do it better. And she used a diffusion model and she managed to reduce it so that we had like much less of a hallucination at the orange. And we only had, I think it was 68 points that were husband, wife, and single. So using a different way of generating synthetic data, she was able to get the synthetic data to be closer to the real data. And, this is really great, kind of, but it really begs the question, how close can you get to the synthetic data or to the real data before the synthetic data is no longer useful, because it's no longer able to get around data regulation or assure privacy or even add new information to your data when you're going to amplify an existing data set to train an AI model on. And there is no single answer to this question. I think probably it's going to be very, very domain specific. And also, here's my sort of soapbox. I think it's going to be use specific. So for example, in this data set, and especially the one that we had before it, you might have a synthetic data set that would be valid and useful if you were interested in answering a research question or basing policy on age and income and gender. But you probably would not want to use that same data set for the ones where the hallucinations are happening. And you would have to know where those are in order to be able to know where you and what you should use the data set. Or if you're going to load it up or put it onto some sort of data repository and make it available for other people to use, those people should also know where these hallucinations and where the fidelities are. So I just want to show this slide too, because we've been trying to think, how can we make these things clearer so that we can talk about the importance of them without having to scare a whole presentation with this splom. So we used some visualization resources and did a similar exercise with the Swedish population data, and then was able to ask this data, the real on the left and the synthetic on the right, different intersectional questions. So for example, we asked the data set, where in Sweden do you have the highest percentage of adults with a university education? And the answer, of course, is Stockholm. Then we asked the same question, a 3-point intersection of age, educational level, and geography. Where do you have them in Sweden? And in the synthetic data that we generated, it was in Östergötland. Now, I'm based at Linköping University, so I think that's a great answer, but it's maybe not the right answer. And we can have a question about what's right and what isn't and truth and all things, but I think it shows quite clearly that maybe the data from the synthetic data set would not be useful if you're going to be using it to, I don't know, make social policy around education, and you need to know the educational levels, for example. So one of the things we're taking away from this research is we have to try to figure out how to make this type of data transparent and ask ourselves, and that's why I'm like here speaking with you guys today, what sort of guardrails or at least tools do we want to have for transparency and reproducibility? Now, this is not the first time I'm asking David these questions. So we had a workshop last year, and we brought over some people from the UK Data Service as well. And we had another workshop in September about these things. And we've been like speaking with people from different data repositories at universities around Sweden too. And what we've ended up doing is creating both a policy suggestion, that's the blue document there. I can send you references to them later if you want. About what sort of README and metadata elements we think synthetic data sets should have, synthetic structured data, if you're going to be depositing them in an open science repository. And I know that you guys at the SND have also produced a document about that as well, the Managing and Publishing Synthetic Research Data, which is available on, I guess, your websites as well. And I've used some of the like innovation and impact money that we can access at Linköping University with for a spin-off where we've used a programmer to try to figure out different ways of analyzing real and synthetic data and making these hallucinations and the fidelities very visible in the data, and then trying to figure out how to create both useful for the researcher, but also printable or watermarkable ways of ensuring that the data set will have that information with it wherever it travels. We haven't really finished that yet. It's kind of hard. Turns out I'm a better gender studies professor than a computer programming leader, but it's really, really interesting and really fun. And one of the things that we've done from that as well is lift out the metadata part of it and just take it outside, because that one's basically done and ready for testing. Lift it outside of our development area and put it online and call it a README creator, which is basically a prompting interface to get anybody who's thinking about depositing synthetic data to answer some of the questions that our workshops throughout the course of the last year have started to identify as being really important. And these questions both talk about the relationship between the real data and the synthetic data and try to make that clear and transparent for potential users of the synthetic data, but also think about the data as both a product and a process. So we're asking people in their readmes to both analyze the data itself for example, intersectional hallucinations or missing edge cases, things that you don't necessarily think about in the first iterations of synthesization, but which are going to be happening in your synthetic data and will make its use cases specific to particular, topics. But then also asking people to be really clear and transparent about how it was generated. Was it a generative adversarial network that you use? What sort of heat did you use? What is it? Was it a diffusion model? What sort of training data did you use? And where do you have the code for that now? Is there a DOI for that and for your data? What is reusable? What isn't reusable? Putting all that together. Now, the QR code brings you to that README creator. So David said it was okay if I asked you to go, if you want to go out and just test it, try it out, and let us know if there are questions you think that we should have on there that we don't have on there. Aspects of synthetic data that you think should be really useful for other people to know about that we're not asking about. Or if there's questions on there that you think maybe aren't relevant and that you don't understand why they're there. This is all like, we're all in the conversation about this with the different actors in the open science community right now. We're really interested in your feedback. So if you get a chance, please go out there and use the README. It'd be really great to know what you think about it. And finally, I want to say thank you to both the people I work with, especially Sagi Haji Sharif and Yin He, who are the ones that have helped me with the data generation and the data visualization, but then also our funders. So this is funding, we've gotten funding from WASP-HS, but also Linköping University, Avancerad Digitalisering, Vinnova, the Norrköping Visualization Center, Infravis, and Fair AI Data, which is the spinoff that did the programming for this. So I think, David, that is it.